given the distribution 2 normal, the question is show that the maximum likelihood estimation does not exist at all. So how do we solve for this? You have to subscribe to this channel for you to get more on this. So we follow the procedure of solving the maximum likelihood estimation. First thing we do is to take the likelihood function. The likelihood function will give the product of this. So if we take the product, we will arrive at something like this. Raised to the power of n exponential summation of xi all over 2 plus 1 all over square root of 2 pi exponential summation of xi minus mu all squared all over 2 sigma squared. So this is what we get. The next thing we do is just to rearrange this so that we will follow the procedure for maximum likelihood estimation. So let's rearrange. We can rearrange it like this. 2 pi minus n all over 2 exponential summation of xi all over 2 plus minus n all over 2 exponential summation of xi minus mu all squared all over 2 sigma squared, which is equal to, you can still rearrange it further, exponential summation of xi all over 2 plus 2 pi minus n all over 2 times sigma minus n all over 2 exponential summation of xi minus mu all squared all over 2 sigma squared. So the next thing, this is our likelihood function. We take the log, So in taking the log, we come over to this place. We say being f of x min sigma squared. If we take the log of this, we'll have 1 all over 2. If we take the log of that, we'll have n all over 2 min 2 pi minus summation of xi all over 2. We take the log of that, we have n all over 2, I mean this, min 2 pi. We take the log of this, we have minus n all over 2, min sigma. If we take the log of this, we have minus summation of xi minus mu all squared all over 2 sigma squared. The next thing to do, let's call this equation star. The next thing to do is to take the differential. So differentiate with respect to mu. If you differentiate with respect to mu, we have f of x mu all over the mean should be equal to 1 all over 2. If we differentiate this, because there is no mean, we have minus 0. We differentiate this, there is no mean here, minus 0. We differentiate this, since there is no mean, we have minus 0. Including this, there is no mean, we have minus 0. If we differentiate this, we get minus 2 sigma xi minus mean 2 minus 1 times minus 1 because of the mean all over 2 sigma squared, equating to 0. We have 1 all over 2 minus, because of this minus sign, here we come to plus, so 2 xi minus mean all over 2 sigma squared. This we cancel this. This already will come to 0, so we'll be left with summation of xi minus mean will be equal to 0. So if you take the sum here, we have summation of xi minus, take this, we have n mean equal to 0. So it means summation of xi is equal to n mean. That means mean estimates is equal to summation of xi all over n, which is the sample mean. Which is the sample mean. The mean can give us that. The next thing to do is to differentiate with respect to sigma squared to see if actually the maximum likelihood estimation exists or not. So we come over to this place. So from equation star, differentiate with respect to sigma squared. So we have mean sigma squared to be equal to. Now we are differentiating with respect to sigma squared. We have 1 all over 2. If we differentiate this, we get 0, minus 0, but there is no sigma here. This and this 2, we get 0, minus 0, minus 0. If we differentiate this, it will now be 2 n all over 2 times 1 over sigma. So it will be n all over 2 sigma. If we differentiate this with respect to sigma, for me to differentiate this, we will use what is called the quotient rule in differentiation. And the quotient rule states that v du all over the sigma squared minus u dv all over the sigma squared all over v squared, which implies that we want to differentiate this. There is a minus sign already, so we have this as a summation of x mean all over 2 sigma squared. Let this be our u, this be our v. It implies that v, we can put v 2 sigma squared times du all over the sigma here to give us 0 times 0 minus u, this is our u, summation of xi minus mean dv all over the sigma squared will give us 2 divided by 2 sigma squared all squared. So this one, if we rearrange it, it will give us this is 0, this is minus 2 sigma xi minus mu all over 4 sigma 4. So this will cancel this to give us minus sigma xi minus mu all over 2 sigma 4. So this is what we write here. Because of this negative sign, it changes to plus. So we have summation of xi minus mu all over 2 sigma 4. So if we differentiate this function, this is what we get, and that is what we put here. So equating to 0, we have 1 all over 2 minus n all over 2 sigma plus summation of xi minus mu all over 2 sigma 4 is equal to 0, which implies that this is 0, so we have minus n all over 2 sigma is equal to minus, if this goes over here, summation of xi minus mu all over 2 sigma 4. So this will cancel this. So it implies that we'll go back to this place to look for our sigma. It means here we can cross multiply so if we cross multiply there we have 2 sigma 4 all over 2 sigma is equal to summation of xi minus mu all over 2 sigma 4 all over n. So this will cancel this. This will also cancel this to give us 3 here. To the summation of xi minus mu all over n. Yes, this is not a variance because it has q on it. It's not a variance. So it means that the variance is not closed under the moment the maximum likelihood estimation. But the mean here, the mean can give us a sample mean, but the variance does not work. So it means that it does not exist. The maximum likelihood estimation for the equation given does not exist, since the variance does not have a closed answer, meaning that mu sigma q does not exist for the equation given, since the parameters are not uniquely maximized. Since the parameters are not uniquely maximized.